Alright, so we are finishing up 12-4 today, talking about segment lengths, dealing with circles, right? So chapter 12 is in circles, so we're talking about segment lengths specifically. Now, there's a theorem. This is a three-pronged theorem. It says for a given point and circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and circle. So, key words here that we want to bring up. First of all, we have a product, right? The product here is constant. So we're multiplying something. What are we multiplying? We're multiplying the lengths of the two segments from the point to the circle. Okay, so first of all, in each of these pictures we have point P. We're specifically dealing with point P here, and point P here, right? So let's look at case 1. It says from point P, if I'm taking the lengths, there's two lengths from point P drawn here to the circle. Notice it's not saying the shortest distance, it's just saying any length from point P to the circle. From point P to the circle along this pink line here, one of them, if we're starting at this point, one of the lengths is A. So I'm multiplying A times, well, what's the other length along that same line? The other length would be B, right? So along that same line, not changing directions here, along that same line, the two distances are A and B, which means I am multiplying product A times B. Well, from that same point, I can take two other lengths to the circle. So here's one, it's length C, and the other one along that same line is length D. So again, I'm multiplying C times D, and those products should be equal. The product is constant. We're going to prove this later at the end of this video. It's not that complicated of a proof. It has to do with, drawing a triangle here and drawing a triangle there. Not too complicated of a proof, okay? So don't panic when I say we're going to prove that there. But that's kind of the concept here, is that we're looking at how to find lengths from a point to the circle. So in this case, case 1 here, that's just dealing with when it's inside the circle. In case 2, we are dealing with one of the cases where P is outside of the circle. So one of the cases where P is outside the circle. So again, let's trace along the pink line here first. So if I have from P along the pink line to the circle, I travel along the pink line, I'm going, and I stop on the circle. What's that distance? Well, that's a distance of y. Well, again, along the same line, I'm traveling from the same point along the line. I have this whole distance here now, which is what? It's not a common mistake is to say, oh, it's just the other variable, z. Well, it's not just the other variable, it's y plus z, which is this entire length here. Okay, so along the same line, that whole yellow segment is y plus z. So we're multiplying, again, we're dealing with product, we're multiplying those lengths together. So now let's go along the other direction. Now we're going along the blue line here. When I'm going along the blue line, my first length, again, from P, I'm starting at P, along the blue line I get W. So I have W times this entire length here, again, starting at the same point, along the same line. I have this whole yellow segment here, which is how long? Well, it's not just X, it's W plus X, right? The entire length here is W plus X. So I'm multiplying those things together. And again, those products will be constant. Same concept here. Little different in this case, though. Same concept, something a little funky pops up here. And yes, I just said funky. If we're starting with point P, and I'm going along the pink line, let's go along the pink line first, then what will happen? Well, first I'm going to go with y, right? I run into the circle. How far did I go? I went y. Then y plus z, that was too far. Y plus z, I'm traveling. I'm now here. This whole segment is them added together, right? So I'm multiplying those two distances together. Well, along the blue line now, same thing. I start at the point P. I'm traveling to the circle. That's a length of t. Well, I have to do the same path again. It's along the same line. Well, I only hit the circle that one time because it's tangent, which means I only go the length of t again. So in this case, I have to go along t times t, which is t squared. That's where this t squared comes from. Okay, so regardless, even though there's one line, you have to take that path twice. Okay, we're going to look at some examples as to how that actually plays out. Not too complicated. And I would not suggest you memorize w plus x times w, y plus z times y. Don't waste your brain space on that. Just know, from that point, trace the two paths, multiply the distances. So whatever point they give you, trace the two paths, multiply the distances. Okay? Let's look at some examples. So, we have an example here. Let's go with some specific numbers here. So these are not labeled yet for you. Let's call this point P again. Okay? If I know that this length here, actually I drew this wrong. I just realized I drew this wrong. So maybe this is not a good one to start with. Let's fix this here. So if I start with this length here and this length here, that's what I wanted. I can say that this is a length of 11, this is a length of 20, this is a length of 13, and this we want to solve for is C. Well, again, starting at my point, starting here, I want to travel along one of my two paths. So I'm going to pick this path first, the higher of the two paths. That's a length of 11 times along the same path, right? Along the same path. How long is this length here? Well, I went 11 and then 20 more, which is 11 plus 20, right? Now I'm going to switch directions here. I'm now going to go along this path here. I went a length of 13 times same path, 13 plus C. 13 plus C. And those must be equal to each other, right? So those are the two paths. They must be equal to each other. So we can just say this is, I think it's easier actually to multiply it when it's like this. If I distribute this through, 11 times 11 is 121. 11 times 20 is 220 equals 13 times 13 is 169 plus 13c, which this would give you 341 equals 169 plus 13c, right? It's 169. Subtract 169 from both sides, minus 169. You would get 172 equals 13c, and you divide both sides by 13, you end up with c equals, that would be, let's just call it 172 over 13, because 13 doesn't go unevenly, so we'd be done. 172 over 13. Alright, so that's kind of how that plays out. Now, if I have, let's go with example 2 here. If I know that this is x, and I know that this here is 4, and this here is 12. Let's again call this point P, just for continuity's sake. Now, if I'm traveling along the first path, let's go this one. I have a length of 4, and then a length of 4 plus 12, or 16. So I have 4 times 16. If you don't want to write it out with plus like we did before, with the variable you have to. You can't combine those. But if you don't want to write out with plus the numbers because you're too cool for that or something, that's fine. Write it out as 16. Now the other path, though, is what? We have x, same path, x again. So we get x squared. 4 times 16 is 64, equals x squared. Therefore, x equals 8. And you're done. Okay, let's look at another problem. Let's see here. Let's ignore this side, because I don't want to do that one anymore. I just changed my mind. I realize I haven't done this one. Okay, I haven't done this problem yet. So, if I know that this length here is 5, and this, actually, you know what, I just realized I do want to do that problem, so I'm not going to erase it. So let's go back here. I'm going to draw, we're still going to do the example that I was doing, but if I know this length here is 5, and this length here is 10, and this length here is, let's say, 8, and I want to find x. Again, this is the point that I care about. Let's call that point P. Along one of my lines, I have a length of 10, and in the other direction, a length of 5, right? Clearly, it's not drawn to scale, by the way. A length of 10, a length of 5, so I get 10 times 5, equals, other path, a length of 8 and a length of x, right? So I get 8 times x from that point P. Just multiply these together, you get 50 equals 8x. Divide both sides by 8, and you get x equals 50 over 8, which 2 goes into both those, you get 25 over 4. You can leave it at that. Now, one thing I did want to bring up here is it can get tricky if you have something like a variable here, right? So this is a length of x, and let's say that this is a length of 4. And then up top here we have a length of, let's say this is 2 and this is 6. So again, same concept that we did before. Starting at this point, follow one of my paths. I have first a length of x. Follow the same path. This new length is now x plus 4. Equals, top path now, length of 2, times a length of, in fact I'm going to make, yeah, we can do this, 2 plus 6, which is 8. So we end up with x squared plus 4x, right? We distribute through. X squared plus 4x equals 16. Subtract 16 from both sides because we're going to have to use quadratic formula, it looks like. This is not factorable, so you'd have to use quadratic formula, which I'll write in the middle here. Give me some space here for a nice little box. We have x equals negative b plus or minus the square root b squared minus 4ac all over 2a, right? There's a little song for that. Goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Isn't that fun? Isn't that fun? So a little pop goes the weasel action there. Anyway, here we go. So negative b. Again, the coefficient here is a, coefficient here is b, coefficient here is c, or the constant in that case. So negative b would be negative 4 plus or minus 4 squared is 16 minus 4 times 1 times negative 16 all over 2 times 1. This gives us, I don't know why I even have this here. This gives us negative 4 plus or minus the square root of 16, the negative 4, and the negative 16 make a positive, so plus 64. So 16 plus 64, which is 80, all over 2. 80, the square root of 80 can be simplified. Let me shorten this to give us some space. The square root of 80 can be simplified to 4 rad 5, and in case you don't remember how to do that, I'm going to make some space up here. If you look at the factor tree of 80, it's 16 times 5, right? And this is 4 times 4, which means we have a set of twins, right? We have a pair. So this becomes negative 4 plus or minus 4 rad 5. The 5 is left behind in this factor tree, all over 2. I can divide each thing by 2, leaving me with, and ta-da, the answer would be negative 2 plus or minus 2 rad 5, right? Dividing each of these terms by 2. And this would be your answer. So sometimes algebra can come into play here, right? It can be a little tricky. Anyway, there's a couple more examples. I'm going to do them in the next part because I'm out of time. Okay? So watch part 2, and I swear I'll let you enjoy the rest of your day. Bye, guys.